G'day. So I thought I'd just record a video to explain what's happening. Such. I'm also going to put that back on. So what's happening? I'll get rid of that. These are nodes that I added here. I'll actually re-enable this so it's a bit faster. What is happening is this geometry here. So if we go into, oops, I'm gonna get out of it. Like that. So I've actually disabled it. So just turn this back on. What's happening is if I turn this off, actually, I think it might be better if I go ray intersect. What should happen is that should actually just change the not working. Okay, for some reason it's not doing it. What would normally happen is so the particles are spawning inside the collision here. So a quick show. If I turn off the display and I start doing it, what you're gonna find is you're gonna see like some of this happening here, where it is being pushed out quite visibly across stuff. So there's a few ways we can fix this. One is by pulling it in a bit, obviously. But another way I'm going to show you here is by using point clouds. And it's quite simple how we're going to do this. I'm going to grab in side of here. I'm going to jump back out. I'm going to go all the way up to here. I'm going to put a null down here. Out, geo. Grab that. Go back into here. Somehow that's not giving me the right one. That's really annoying. Windows doesn't let the copy. There we go. Okay, out geo. So we got that. I think my geometry is a bit different to what you've given me, what you had, because mine's an SCL, yours an OBJ. So what we're going to do is we're going to convert this into a BDB first of all. So BDB from polygons. And what have you got your size as? About that much. That's pretty good. So I'm going to do the same. Oops. Same. I'm going to delete channels because I accidentally turned that on. We can probably go a bit higher, like 0.3 or 0.2. 0.2 probably good. Okay, I'm going to go click on fill interior because we're going to need that. Now, what that does actually, whoops, don't want that one. Turn you off, and I should, if I go like volume slice here, you might be able to see it. Nope. Okay. If I turn this down, would that show it? Kind of. Not. It's not really showing me. Let's go to a tree. Visualize tree. Let's see what's happening here. Let's go active points, and you can see like some of them are. If I now do a clip here, we should see this axis. You should see like these are the color indicates what their value is. And you can see kind of that it's kind of hollow inside here. Well, we want to actually have it filled, so I'm going to turn on fill interior. That should fill the interior, and it does. It's now completely filled. All right, let's just a quick visualization of that. Now what we want to do is we want to eat away based on the particles here. And you are eating away. How's it eating away? Right, so it's actually eating it away like that. So what I'm going to do is I'm going to copy that out. I'm going to turn on delete selected. So, and then I'm going to do a volume wrangle. Now you don't have to worry about the wrangles or vects or anything like that. I'll explain it best I can. Actually, I'll try to use a volume drop. Might be a bit better. All right. So what we want to do is we want to figure out what the value is for these points. So I'm going to do another one. I'm going to do another volume. What's it? VDB tree. Turn these off. Points with values, and then I'm going to go flip mode again, and that's on. And if I rasterize to like 0.1 sort of thing, so we can actually see a little bit better. What we're going to try and do is do like a show what the number. Well, show what these numbers are. So there should be a way. The VDB float is the one we want, I believe. Let's go visualize. I think it's visualize attribute we want. Right now it's going to visualize the P. I want the VDB float, and we can see on a scale of like 0 to 1. So I think we need 1, and I think it's -1. That's what we want. No, it is 1 to 0. I'm forgetting how how the SDF field works. Obviously, didn't think I did, but okay. Back to 0.02. And what we're going to do is we're going to bring in a point cloud. When we do that is we go PC open. This is a pretty simple one. All we need to do is plug in the position and the file, which would be in op input 2. And then what we do is need to go to PC filter. And I think there should be like PC num found sort of thing. This if statements don't really work well inside of VOPs, they're a bit hard to explain, which is why I like using Vex. But basically, would say, hey, if we found more points in here, then go to here. Otherwise, don't. So what I think I want to do is instead of this, I actually want, instead of PC open, I want to say PC find. PC find is actually faster than PC open. I'm going to delete that. So what I'm also going to do is I'm going to bind input the bind output export, and I want to output to the surface. And what I can do is plug that in. Nothing's not going to do anything. We are doing first surface. Okay. What we want to do is I plug in like a float, like a constant. This might disappear. Right. So what the best thing to do is getting the current. We want to get what the current position is already. Or we can just do like a multiply. But we need to get the current position. So we're going to go PC volume. Volume sample, which is going to sample the volume at the current location. File is going to be the first input. And we can do that too. We can go for second input here like that. So we can plug in that in. Need to plug in P. Need to plug in P in here. Now if I plug that in here, that should be fine. It's going to get primitive number 0. 0 is just going to be the first volume. Okay. Once we've gotten that, I want to multiply it by the amount of points that we find. If we find none, then multiply by 1. So I'm going to say len. I think it's length. Nope. I want len. Where is len? The array length. So what we're getting is we should be getting an array. So right now it's giving me an int a, which is not really what. Oh no, int array, yeah. And that should be giving us the length. Plug that in. Not going to do anything. So if I do a multiply, and we're going to get that. Not quite what we want, really. What we want to do is we want to do like a compare. And what we want to do is we want to say, hey, is this greater than 0. I think that's the one, or is it less than? I think it's less than or equal to. Here we go. Now that will actually eat away at our volume. So what's happening here is in a basic example, we're doing a point cloud, which is basically at the current position, so the position of the voxel, create a sphere. The sphere is about 0.1 radius. We're going to try and get a max of 10 points. Once we have that, that's going to give us a list, what we call an array, of all the points that we found. I am then getting the length of that array, and I'm saying, hey, is it less than or equal to 0? If it is that, then it should give us a true or false statement. Now, true or false is 0 or 1. That means that all we're going to be doing here is multiplying our volume by 0 or 1. If you multiply by 0, then it's just going to come in at 0. But if we multiply by 1, then nothing's going to change. So that's what we're doing. That's now going to eat away at our volume. Might look a bit different to how this is working. But that's what I'm going to be using. We can also use a VDB reshape if we want to. Although I probably wouldn't recommend it since it's going to do that. Right, so that doesn't actually look like it will work. I don't think that'll work then. What a good thing to do is, instead of using a SDF, is we use a density, and that will still work. We just need to plug it into here. And then what we can do is we can do VDB convert, and we can convert that to an SDF. VDB class from fog to SDF. And I'm going to turn the ISO value to the small as I can get it. About there. Let's go 1. It's a bit impacted. And now the VDB reshape will actually work. I'm going to erode it a bit as well. All right. Now that we've got that, what I'm going to do is I'm going to see if that's actually changed anything. Also, I'm going to probably save this out. And I'll pause it here because this might take a little bit. Okay, now that that's done, let's check to see if that's actually fixed our issue. Back to 0. Down to U. I'm not too sure. It looks like it has. Oh, right. I actually need to do the volume first, don't I? Right, so I actually need to do this. Let's go to you. Let's see what you've got going on here. All right. So you've got a collision ground. An easy way to fix collisions on the ground, I found, is to do a boundary. So if I go trig close below, then it will just bound it. And then I can set the boundary on that. Because the head is a bit above, I'm going to get the lowest point, which is negative 0.472. Grab that. I'm just going to copy it. Well, I would actually no. I'll show you the proper method. What you would normally do is you would pull this out. I'm going to say bound. I'm going to create a new null. Out bounds. The bound's going to give us like a box. I'm going to grab into there. I'm going to say hello. I want the let me get the point. I think it's point. Yeah, I want to get no. Let me get bbox. What is it? Bbox Come on. I've forgotten what to do. Should be VBox. Been years since I've actually had to write H script. Don't normally write H script. Give me a second. Alright, I was just being stupid. So it's VBox. The input there, and then we're going to say dy min. And we technically could bring in the other this. I found it be a little bit better, more safer to use this, the outbounds. I'm going to plug it into there like that. What I would normally do is I should go. Nope. There we go. So that's going to give us the. I'm gonna channels expression, total expression. There we go. Now we're actually going to see it's actually going to give us the actual expression that we want. I'm going to keep that. I'm going to the box that we want. So I'm going to just quickly visualize that, and now that'll actually treat the floor like a floor. And it looks like it is. Bank. Let me. I don't know if I can take a snapshot. Can I? Let's take a snapshot. Let's go snip. Grab that. I'm just going to go open. And I want to go back to the frame 34. And I'm just going to see if that looks any different. Quick tip: if you're not, it actually works fast if you don't view it, because it doesn't need to write to the GPU and back to the OpenGL and stuff like that. No, that's good. Okay, so we do actually want to have close below. So close below. Plug that out. I am then going to say, yep, what do you call it? Save the disk. I'm going to pause here as well. Okay, the smoke's now done. Good. All right, so let's now see the topnet. Where's the ground? Oh. I'm going to go back to you. Stopnet. Stop. I'm going to just grab that. I want to get the background to be about the same as the smoke, so that we're not going to get any unnecessary pops. All right, back that up, and then I'm just going to turn off that display. I'm also going to right click and go pixels instead of points. And there you go. It's now working without popping. So to sum up that entire process, the reason it was popping is because when it was spawning in, it was spawning inside the collision, and then what happens is there's a really good video on on the Mario Brothers speedrun where it describes how most collisions are handled. And what happens is, if for say it's in a box and you put and the thing spawns out of the box, it'll push it out to the closest one. It'll push the point outwards. But because it wants to do it in like a single frame, that means it's going to get an incredible velocity. So it'll then have these weird scattering effects. Sometimes it'll even hit inside the wall itself, and then it won't push out. So that's why it could also be doing that. So there you go. There's your fix. Hopefully that helped.